Hi, hello, welcome to my YouTube channel. So today, what I am going to uh, discuss with you all is about management for under the management for engineers subject, right? In our Open University of Sri Lanka. So there are a unit called Unit 5 and also some other units. So in that Operation Management Unit 5, so Session 5 is there, transportation problem in linear programming, right? So linear programming we can discuss, right? So linear programming, uh, so such a different case we have to discuss. So normally commonly what I am discussing is transportation problems, right? So under the transportation problem, so you can see it's a special case of linear programming, right? So it's a special case of linear programming. So this transportation problem is especially belongs to linear programming, right? So here, so it's designed to specifically transportation goods from several sources to several destinations with minimum cost. So we can find the minimum cost there, right? So kind of a thing. So we are transporting in the engineering or in any kind of work, right? So management work, the transportation of goods from several sources to several destinations. There may be two places. So that two places, so several places, I mean transportation of goods from several that sources to several destinations. So there may be two places to transfer some goods. So for that there may be a cost. So for that cost, minimum one we can find there. So here, so structure is a simpler than general linear programming. General linear programming we can do by using the graphical also. So some simplex metrics form. So but here differently we are, especially we are considering about, so linear programming, we use objective functions, constraints, simplex methods we are doing normally. But here in transportation problems, the structure is fixed one, right? So there is a sources, supply points, sources we are calling supply, and destination is there, it is called demand point. So destinations are demand point, sources is supply point. Then transportation cosmetics we have to show. So using the, maybe this is difficult to understand to you all, but when I am go through the questions for examples one, so example one, you will be get clear idea, right? So because of this special structure, we use special algorithm instead of the simplex method, right? So special method we are using here to do this one are, you can see this, what is called, this is a northwest corner method, then least cost method, another method, then Vogel's approximation method. There are there are three methods are there, especially there are three methods are there to find the initial solution. So there are something we have to do to solve this one. So what I'm explaining is, so initial solution is there. So first thing, okay, we are finding first in problem solving initial solution. I mean first we are doing finding a solution, right? So maybe it's a optimal solution, it may be optimal solution, it may be optimal solution, but it may be not an optimal solution. Hari, so in Tamil language as well as Sinhala language, I will explain here also for short outing the questions. So in Tamil, ஸோ நாங்கள் என்ன செய்கிறோம் என்றால், இந்த ஸ்பெஷலான இந்த சொல்யூஷனில் த்ரீ மெத்தட்ஸ் இருக்குது. த்ரீ மெத்தட்ஸையும் யூஸ் பண்ணி நாங்கள் அப்ராக்சிமேட் பண்ணி இந்த சொல்யூஷனை கண்டுபிடிக்கலாம். முதலாவது இந்த கொஷின்ஸை சால்வ் பண்ணுறதுக்கு த்ரீ மெத்தட்ஸ் இருக்குது. ஒன்று வந்து நார்த் வெஸ்ட் கோர்னர் மெத்தட், அடுத்தது வந்து லீஸ்ட் காஸ்ட் மெத்தட், அடுத்தது வந்து வோகல் அப்ராக்சிமேஷன் மெத்தட், ரைட்? ஸோ அதில் இருந்து இது வந்து பேசிக் சொல்யூஷனை ஃபைண்ட் பண்ணுறதுக்கு, ரைட்? இனிஷியல் பேசிக் சொல்யூஷன். ஸோ ஆப்டிமல் சொல்யூஷன் சொன்னால், ஆப்டிமல் என்றால் ஒரு ஒரு மேக்ஸிமமான குட் அவுட்புட், இப்படி திங்க் பண்ணுங்க ரைட். ஸோ ஐ மீன் நாங்கள் என்ன செய்கிறோம்னால் இந்த இதுலேருந்து நாங்கள் ஒப்ஜெக்டிவாக நாங்கள் எடுக்கிறது என்னென்றால் பாருங்க இங்கே மினிமம் டோட்டல் டிரான்ஸ்போர்ட்டேஷன் காஸ்ட் எங்களோட டோட்டல் டிரான்ஸ்போர்ட்டேஷன் காஸ்ட்டை நாங்கள் மினிமம் பண்ணுறோம் ரைட். ஸோ நாங்கள் எங்களோட டிரான்ஸ்போர்ட்டேஷன் காஸ்ட்டை வந்து மினிமம் பண்ணுறோம். அதர்வைஸ் சம்டைம் மினிமம் டைம் டிஸ்டன்ஸ் டிரான்ஸ்போர்ட்டேஷன். But especially we are considering here is transportation cost வந்து நாங்கள் minimize பண்ணிக்கொள்கிறோம் right. So here in our case here little give me some time. So here நாங்கள் வந்து இதோட டிரான்ஸ்போர்ட்டேஷன் காஸ்ட்டை வந்து மினிமைஸ் பண்ணுறோம். ஸோ இதை வந்து ஒரு ஒர்க் வந்து நீங்கள் திங்க் பண்ணிக்கொள்ளுங்க. ஒரு இடத்துல இருந்து இன்னொரு இடத்துக்கு நாங்கள் இன்ஜினியரிங்கில் ஸோ இதாக தான் சொன்னேன் நான் சப்ளை பாயிண்ட் டிமாண்ட் பாயிண்ட். நாங்கள் வந்து ஒரு உதாரணமாக ஒரு இடத்துல நாங்கள் வந்து சிமெண்ட் பேக்ஸை வந்து டிரான்ஸ்போர்ட் பண்ண போகிறோம் ஒரு இடத்துல வந்து இன்னொரு இடத்துக்கு. ஸோ அது வந்து ஃபேக்ட்ரியில் வந்து 3 ஃபேக்ட்ரி. இப்போ ஃபேக்ட்ரிஸ் வந்து சப்ளை பாயிண்ட். ஸோ சப்ளை 3 ஃபேக்ட்ரிஸ் ஆர் திங்க் பண்ணிக்கொள்ளுங்க. 3 ஃபேக்ட்ரிஸ் இருக்குது. ஸோ அந்த 1 2 3 ஃபேக்ட்ரியிலேருந்து நாங்கள் எங்களுக்கு ப்ரிப்பேர் பண்ணுறதை ப்ரொடியூஸ் பண்ணுறதை ஃபேக்ட்ரிஸ் 4 ஃபேக்ட்ரிஸுக்கு நாங்கள் சென்ட் பண்ணணும் ரைட். ஸோ சாரி 3 ஃபேக்ட்ரிஸ்லேருந்து 4 எங்களோட ஸ்டோர்ஸ் இருக்குது. ஸோ 4 ஸ்டோர்ஸில் நாங்கள் போய் அதை கொண்டு போய் அடுக்கி வைக்கணும்னு வச்சுக்கொள்ளுவாங்க. ஸோ 3 ஃபேக்ட்ரிஸ்லேருந்து 4 ஸ்டோர்ஸுக்கு வந்து நாங்கள் சப்ளை பண்ண போகிறோம். ஸோ இப்படி சப்ளை பண்ணுறதுக்கு எங்களுக்கு டிரான்ஸ்போர்ட்டேஷன் காஸ்ட் வரும். டிஃப்ரெண்ட் பிளேசஸில் இது இருக்கலாம். ஸோ அந்த எங்களை ப்ரொடியூஸ் பண்ண இடத்துலேருந்துக்கான தூரங்கள் டிஃப்ரெண்ட்டாக இருக்கலாம். ஸோ இதில் கெப்பாசிட்டிஸ் டிஃப்ரெண்ட்டாக இருக்கலாம். இவ்வளவு தான் கொள்ளக்கூடிய ஃபேக்ட்ரிஸ் ஸ்டோர்ஸ் இருக்கலாம் ரைட். ஸோ ப்ரொடியூஸ் பண்ணுறது டிஃப்ரெண்ட்டாக இருக்கலாம். ஒவ்வொரு ஃபேக்ட்ரிஸும் ப்ரொடியூஸ் பண்ணுற கவுண்ட் வந்து டிஃப்ரெண்ட்டாக இருக்கலாம். ஸோ இதை வச்சுக்கொண்டு எங்களுக்கு 3 இடத்துலேருந்து 4 இடத்துக்கு ட்ரான்ஸ்ஃபர் ஆகுதுன்னு சொன்னால் ஸோ அதை வச்சுக்கொண்டு நாங்கள் திங்க் பண்ணிக்கொள்ளலாம் என்னென்னு சொன்னால் எதில் எங்களுக்கு அதாவது நல்ல ஒரு டிரான்ஸ்போர்ட்டேஷன் காஸ்ட் வந்து மினிமம் ஆகும் எங்களுக்குன்னு திங்க் பண்ணலாம். அதை வந்து ஃபைன் பண்ணி கொள்ளணும். ஏன்னா அப்போ தான் எங்களுக்கு டிரான்ஸ்போர்ட்டேஷன் காஸ்ட் மினிமம் ஆக வேண்டியது எங்களுக்கு நார்மலாக மேனேஜ்மெண்ட் பண்ணும்போது தேவைப்படுற ஒரு விஷயம். ஸோ டு ஐடென்டிஃபை தட் அதை ஐடென்டிஃபை பண்ணுறதுக்கு 3 மெத்தட் இருக்குது. நார்த் வெஸ்ட் கார்னர் மெத்தட், லீஸ்ட் காஸ்ட் மெத்தட், வோகல் அப்ளிகேஷன் மெத்தட் இருக்குது ரைட். ஸோ அதுலேருந்து இது வந்து இனிஷியல் சொல்யூஷன். இது வந்து மேபி இது நாங்கள் ஃபைண்ட் பண்ணுற ஃபஸ்ட் சொல்யூஷன் வந்து நான் செய்கிற மெத்தடில் காட்டுவேன். இது இனிஷியல் சொல்யூஷன். அந்த இனிஷியல் பேசிக் சொல்யூஷன் மேபி ஆப்டிமல் ஒன், அதான் உங்களுக்கு ஆப்டிமமானதாக இருக்கலாம். அல்லது இது வந்து ஆப்டிமம் ஆகிறதுக்கு நாங்கள் ஆப்டிமல் சொல்யூஷனை செக் பண்ணி ஆப்டிமல் சொல்யூஷன் கெட் பண்ணுறதுக்கு 2 ways இருக்குது. Modi method இருக்குது, stepping stone method இருக்குது right. So I will show Modi method to solve how to find the optimum solution right. So let's see right. Let's see this question right. Okay, boddak singalayum boddak kiyanam then singalayum balamu then අපිට අපි එන්ජිනියර්ස් විදියට අපි වැඩ කරනකොට මැනේජ්මන්ට් පාර්ට් එකෙන් අපිට ෆැක්ටරිස් 3ක් තියෙනවා කියලා හිතන්න. හරි ප්‍රොඩියුස් වෙනවානේ ෆැක්ටරිස් වලින්. ඒක සප්ලයි තන I mean අපි ස්ටෝර් තියෙන තනක් තියෙනවා 4ක් තියෙනවා කියලා හිතන්න. එතකොට සප්ලයි ප්‍රොඩියුස් කරන ෆැක්ටරිස් 3 ඉඳන් 4 තනකට I mean එකක් කියලා අපිට මොකක්ද තියන්නේ අපිට ස්ටෝර්ස් තියෙනවා. ෆැක්ටරි ඉඳන් ස්ටෝර්ස් එකට අපි ට්‍රාන්ස්පෝර්ට් කරනවානේ. ෆැක්ටරිස් එකට ස්ටෝර්ස් එකට කැපැසිටි තියෙනවා මෙච්චර ප්‍රමාණයකට තියාගන්න පුළුවන් කියලා. අපි අපේ ෆැක්ටරි කැපැසිටි ප්‍රොඩියුස් කැපැසිටි තියෙනවා මෙච්චර ප්‍රමාණයකට ප්‍රොඩියුස් කරන්න පුළුවන් කියලා එකක් තියෙනවා. වෙන දුරට තියන්නත් පුළුවන්. හරි ඒවා එකතු වෙලා අපි මේවා ට්‍රාන්ස්පෝර්ට් කරලා කොයි අපි ස්ටෝර් කරන්න ඕන අනිවාර්යයෙන්ම. එතකොට ප්‍රොඩියුස් කරන්න ස්ටෝර් එකට දාන්න ඕන. එහෙම කරනකොට අපි අනිවාර්යයෙන්ම මෙන්න ට්‍රාන්ස්පෝර්ට් කරන්න ට්‍රාන්ස්පෝර්ට් කොස්ට් එකක් තියෙනවා. ඒ කොස්ට් එක අපි කියන්නේ අඩු කරන්න ඕන. ඒක අඩු කරන්න solution එක තියෙනවා. එතකොට අපිට මේ equation එක කරනකොට initial solution කියලා තියෙනවා, optimum solution කියලා තියෙනවා. ඒක initial solution කියන අපි පළවෙනි එකට ගන්න solution එක. හරි, ඊට පස්සේ optimum solution ද කියලා බලලා ඒක optimum solution එක find out කරන්න ඕන. ඒකට මේ ක්‍රම දෙකක් තියෙනවා, Modi method කියලා stepping stone method තියෙනවා. මම Modi method මෙතන discuss කරනවා. හරි, ඒක northwest corner method and least cost method Vogel application method එකකින් අපි බලන්නේ initial solution එක විතරයි. ඒක ඒවා කොහොමද බලන්නේ කියලා මම අද කියලා දෙනවා. හරි, දැන් ඉංග්‍රීසි වලින් කියලා දෙනවා, තමිල් වලින් කියලා දෙනවා, සිංහල වලින් කියලා දෙනවා. දැන් බලමු. හරි, දැන් අපිට මේක transportation cost එක minimize කරන්න ඕන. එහෙම තමයි අපේ idea එක තියෙනවා. හරි, දැන් බලමු මේක objective එක බලවන්නේ minimize the total transportation cost එක. right, நாங்க வந்து இது total minimize cost එක வந்து நாங்க குறைக்கிறதுக்கு தான் நாங்க பாப்போமா. We are going to see about the minimize the total transportation cost here, right, okay, this the thing content, the introduction thing what I plan to discuss with you, right? So now we will move with an example, right? We will move with an example, right? Right. Okay, I will move with some other software called we will discuss this one more. Right, okay, we will discuss here, right? So right, so first example, so there I am going to discuss first northwest corner method, right? So we will discuss here. Northwest corner method, right? Northwest corner method mean this is north, right? So this is north, this is west, right? So here, so this corner is here, right? Normally when you are taking a question, so this corner හරි, අපි බලන්නේ northwest corner method එකකින් north එක මේක, west එක මේක, දැන් මේ corner තමයි කියන්නේ northwest corner. හරි, நாங்க வந்து northwest corner methodல பார்க்க போறோம். So northwest cornerல இந்த corner சொல்ற northwest corner is north, is west. So in table in this direction we have to think, in this direction we have to think, right? So northwest corner method example විදියට මම කරන්නම්. So I will do an example here. So this is same. So these are suppliers, right? So these are suppliers. Same. So there are destinations also. There destinations mean I already told you. So those are our stores, right? Stores secret nama, we will give a name, right? So now name kudupam. So say A, then B, then C, then D, right? So here these are supply. So normally in table we have to put this side supply. right? So see here, this side normally our demand will be there. Here demand, right? Here supplies are, you can see supplies. So supplies are, say, S1, supply 1, and supply 2, and supply 3. I mean these are factories, right? These are factories, and these are A, B, C, D are our store, right? We are storing there, right? These are our stores, right? Okay, we will move to another color. Okay, so here the inside our cost. So S1 to A, I mean from supply point S1 to the location of A, for the transportation cost is, they are telling 10, right? They are giving us 10 is the cost, right? So here they are giving us from S1 to B 2. So here 20, right? So here 11, right? Like that here 12, right? Here 5, 7, right? So for example, from S2 to 7, if we want to transport a good, so the cost of that per unit cost is unit transport, unit of transport cost amount is this in rupees, maybe, right? In rupees, 4 rupee, like this, 4 rupee from S3 to A for per unit, 1 unit, right? ஒரு யூனிட்டை டிரான்ஸ்போர்ட் பண்ணுறதுக்கு எங்களுக்கு நான் எழுதுகிற க்ரீன் கலர் எழுதுதெல்லாம் வந்து ஒரு யூனிட்டை டிரான்ஸ்போர்ட் பண்ணுறதுக்கான காஸ்ட் இன் ருபீஸ், ரைட்? ஓகே, අද කැපැසිටි ඉස් දෙයක් නෝ. So capacity is there. මේවා ඔක්කොම අපේ S1 තන ඉඳන් S2, මෙන්න මේ S1 ෆැක්ටරි ඉඳන් SA කියලා ස්ටෝර් එකට ට්‍රාන්ස්පෝර්ට් කරන්න කොස්ට් එකක් තියෙනවනේ. यूनिट එකට තියෙන කොස්ට් එකක්, ඒක 10 රුපී. හරි, 10 රුපී per unit එකට. හරි, ඒවා තමයි මේක දාලා තියෙන ඔක්කොම. දැන් S3 ඉඳන් C එකට ට්‍රාන්ස්පෝර්ට් කරන ඒවා 16 කියලා දාලා තියෙනවා. හරි, මේවා තමයි මෙතන දාලා තියෙන්නේ. හරි, දැන් මේකට මේවා තියෙනවනේ පොඩ්ඩක් ඉන්න. Okay, there are here, there is the capacity is there, right? So capacity here for, I mean demand is there, right? So demand mean them we can see in A store only, I mean A store only can have 5, right? Then here 15, say 15 cement bags only they can keep. No, at a time 15. Here also 15 cement bags they can keep. Okay, then the producing thing, S1 factory in produce karannawa, so we are producing from S1 factories 15. Then here 25. So here S3 factory can produce 10. So this is the capacity. Then so these are the cost and the basic thing. This will be given to you in the question paper. So normally it is given. So what you have to do is, first we have to do this part. So we have to check that demand, whether demand is equal to supply. Total demand is equal to total supply, right? So we have to check whether this one, check, right? You have to check this one. So checking is 5 plus 15 plus 15 plus 15. So altogether 45 and 550, right? So I am writing here like this. So altogether it is 50, right? This side 5 plus 15 plus 15 plus 15 is 50. So here 15 plus 25 is say 30, 40, then here plus 10 is 50. Altogether 50, right? So check demand for supply check is okay. So it is fine. So if it is not, what we have to do is we have to add a dummy here, right? S1. Here we can put a dummy, and here we have to put in here a row. We have to add a row, and we have to put dummy, and so where it is lacking, right? Here, if it is lacking in the row, we have to put here. Otherwise, if it is lacking in the supply, we have to put there, right? Normally in row, we have to put a dummy here. We have to write dummy and add one row, and there's no cost, no. So 0, 0, 0, 0, and for our dummy, maybe if it is say this is total supply is 49. So there is a 1 is lacking. So we have to put 1 there, and we have to add together, and we have to say it is 50. Okay, we have to say it is 50. So like that we have to initiate that one, right? So it is a one initial step you have to do, right? One initial step you have to do. Okay, I will cover everything here, right? Okay, මම කියන්න මේක මෙතන බලනකොට මේවා ඔක්කොම එකතු කරනවා 5 plus 15 plus 15 plus 50 is 50 එනවනේ. එතකොට සප්ලයි එක එකතු කරනවා 15 plus 25 for 10. මේවා එකතු කරනකොට 50 එන්න ඕනේ. නැත්තම් මේක 49 කියලා ආවේ කියලා හිතන්නකෝ. එතකොට එකක් අඩු. එතකොට අඩු කියලා මෙතන ඩම්මි කියලා මෙතන රෝ එකක් ලියලා මෙතන මේවා ඔක්කොම කොස්ට් එක 000 බිඳුව 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 කියලා දාලා මෙතන එකක් කියලා දාන්න ඕන සප්ලයි එක. එතකොට මේවා ඔක්කොම 50 කියලා පෙන්වන්න ඕන. එතකොට ටේබල් එක මේ විදියට පටන් අරගෙන අපි වැඩ ටික පටන් ගන්න ඕන ඉස්සරහට. ඒකයි එහෙම ආවොත් මොකද කරන්න ඕන කියලා. right? So தமிழ்ல சொல்றேன். here இதுல 5 10 15 15 மூணையும் கூட்டினீங்கன்னா 50 வரும். so இங்க 15 25 10 ஐம்பதையும் கூட்டிங்கன்னா 50 வரும். so இதுல ஒன்று குறைஞ்சிட்டுன்னு வெச்சுக்கொள்ளுங்க. இதுல 9 இருக்கு. so அப்படி இருந்தால் so what we have to do is நாங்க என்ன செய்யணும்னு சொன்னால் so ஒன்று போடணும் இதுல. so அதனால நாங்க இதுல டம்மி ஒரு ரோ எட் பண்ணி அந்த ரோல காஸ்ட் எல்லாம் 0 0 0 0 ன்னு போட்டு greenல so இங்க ஒன்றுன்னு போட்டு மொத்தம் 50 ன்னு காட்டி ஈக்குவல் பண்ணி காட்டணும். so that is for we have to, otherwise we have to add dummy, right? okay, that is what we have to do initial. so இப்போ டேபிள் வந்துட்டு ஸோ இதில் சொல்யூஷனை கண்டுபிடிக்கணும்னா நாங்கள் என்ன மெத்தட் ஃபஸ்ட் யூஸ் பண்ணுறோம் நார்த் வெஸ்ட் கோர்னர் மெத்தட். ஸோ இந்த மெத்தட் எப்படி செய்யணும்னு பார்ப்போம். right, we will move to do that one, right? so I will use black color, right? okay, so here நான் சொன்னதுல northwest corner, so I told northwest corner method, right? so northwest corner method, here you can see, so normally northwest corner upper one is this one. so then northwest corner, this is the northwest corner. so northwest corner of this table is this one, right? so there are several table mean, so here there are tables mean. so northwest corner most table point is this one, right? so that is what here I am giving the allocation. so maximum allocation I have to give here. so how to give here? so maximum allocation here, this is 15, supply is 15 here. so from 15 I can maximum give is 5, demand is 5. so metana here 5 is there, so maximum I can give is 5 here. so what I can do is 15 I have to give to this corner. my selected cell is this one. For this cell northwest corner cell is this one. so maximum I can give is 5, right? demand is 5, so supply is more, but I can only give 5, no? so more than demand I can't give. so 5, so I am reducing 5 here, minus 5. now its availability is 10. here what I am giving is 5 here, right? 5 here. so altogether this line, this column is finished, right? so I am putting like this, I am cutting this column, right? so I am cutting this column, so minus 5. so already 5 is finished, so this is 0, so this is 0, right? so this row, this column, now it is finished, right? so let's see here. so it is finished. now first step is this one. so next northwest corner is which one is northwest corner? so this is our available cells. So this is the northwest corner cell now. 2 is the northwest corner cell. Here, so maximum allocation I can give for this one is 15. So but I have 10. 10 supply I have, 15 I can give. So 10 I am giving 10. So 10 equal to 0. So 10 I am giving here. I am giving 10 here, right? So I am giving 10 here. So I have to reduce 10. Demand of 10 is reduced by 10. So demand is reduced, 15 is reduced by 10. So now I have availability, demand is 5 now. So I can't cut this one, but here it is 0 now. So now I can cut this row. Now I can cut this row because there is no availability, right? So there is no any availability. So this row is now not available now, right? So let's see. So I already allocated 10 here and 5 here. Let's see, the balance cells are this one. These 6 cells are the balance cells. So among this northwest corner cell is this one, this 7. This cell is the among this northwest corner cell is this one. So for this cell, maximum allocation I can give is only 5, right? So 5 availability is there, demand is 5. So I am going to reduce 5 here, 5 here. Now I have availability is 20. So I am going to give 5 here. So after that I will reduce 5 here. So now it's 0. Now the cell is, I have to cut. So the cell, the column I have to cut because 0, right? So next what we have to do here, 9, 20, 16, 18, right? So this, among this, which one is the northwest corner cell? This one, right? 9 is the northwest corner cell. So for this cell, maximum allocation I can give is 15. So demand is 15. So here availability is 20. So minus 15 equal to 5. Balance is 5. So here I am giving 15 here. So minus 15 altogether 0. So I am going to cut this column as well because 0, right? So now available northwest corner is this, only 2 is there, no? So this one. So you can directly give this 5 and 10. Balance is this, no? Only 2. So I am allocating 5 here. So this will automatically become 0. So this is 10 here. So I will give 10 here. Now 10 plus 5 is 15. So I can reduce this one. So no any issue here, right? So we all the allocation we already done. So our initial feasible solution is this one, right? For A, we are supplying S1, from S1 we are supplying for A 5, right? So for B we are supplying from S1 10. For B we are supplying from S2 5. For C we are supplying from S2 15. For D we are supplying from S2 5. So this is the initial basic feasible solution. So initial basic solution, we can find the total cost. For initial basic solution, we are finding the total cost, right? So let's see. For initial basic solution, we are calling this one initial basic solution. Total cost equal to, say, 5 multiplied by 5 units multiplied by 10 rupee per unit. This is 10 rupee per unit, 5. So plus here 10 unit multiplied by 2 plus 5 unit multiplied by 7. 5 unit multiplied by 7 plus 15 multiplied by 9. 5 by 20 plus 18 by 10 by 18, right? So this is our 5 by 10, 10 by 2, 5 by 7, 15 by 9, 5 by 20, 10 by 18. If you add up this thing, so final value will come 520 rupees. Rupees 520, right? So this is the total initial feasible solution. This may be optimal one, may not an optimal one, may be an optimal one, may not an optimal one. So let's see for one, right? So I am checking this one for one, only one question, right? Only one question I am going to check this one. So other than that, other questions the same thing, right? Other questions mean, what I am saying is the way I already told, three ways, right? One is northwest corner method to find the initial basic solution. For the initial basic solution, this one total cost, this initial basic solution, there are other two ways, that is Vogel approximation method and other one is least cost method, right? So those two methods we will I will explain how to find the initial basic solution, right? So other than that, optimality check, optimal solution to find them, we are thinking, right? நாங்கள் பார்க்குறோம் இது ඔප්ටිමමලාන வெளியுදානන්න நாங்கள் චෙක් பண்ணுவோம். අපි බලන්න මේක ඔප්ටිමල්ද කියලා චෙක් කරනවා අපි. හරි? මේක ඔප්ටිමල් සොලියුෂන්ද කියලා චෙක් කරනවා. ඒක අපි අනිත් එක අපි බලනවා. හරි? ඒ ක්‍රමයක තුනටම එකක්. හරි? ඉනිෂියල් බේසික් සොලියුෂන් එක අපි බලන්න එකක් තමයි ක්‍රම තුනක් තියෙන්නේ. ඒ තුනම මම කියලා දෙනවා. අනිත් ඔප්ටිමල් සොලියුෂන් එක බලන්න එක ක්‍රම එකක් තමයි ඔක්කොටම. එක මෝඩි මෙතඩ් කියලා තියෙනවා, ස්ටෙපිං ස්ටෝන් මෙතඩ් කියලා තියෙනවා. මම මෝඩි මෙතඩ් එකෙන් කියලා දෙනවා දැනට. හරි? දැන් මේක බලමු මෝඩි මෙතඩ් එකෙන් කොහොමද වෙනවා කියලා. හරි? හරි. අපි චෙක් කරමු මේක ඉනිෂියල්ද කියලා. මේක ඉනිෂියල් බේසික් සොලියුෂන් එක ඔප්ටිමල්ද කියලා. ඒක ඔප්ටිමලිටි චෙක් කියලා කියනවා. ඒක ඔප්ටිමලිටි චෙක්. So for finding the optimality check, what we are doing is, so for the optimality check, what we are doing is for optimality check. Right? There are some ways to do that. Right? Right. Right. So for the optimality check, so first something we have to do. So first we have to do the degeneracy, right? Degeneracy, there is to check for degeneracy. So there is a check for degeneracy. For degeneracy. There's a equation for that one, m plus n, right? M plus n, right? Minus 1. Sorry. Minus 1 equal to, it should be equal to Cij. Cij means the number of allocated cells. We are telling this one, it should be equal to number of allocated cells. Allocated cells, we have a name, basic cells, right? So allocated cells mean we allocated 5 here, 10 here, 5 here, 15 here. These are allocated cells, 5, 10. Other cells are called non-basic cells. So name are there. For these cells we are calling non-basic cells. We are not allocating anything, right? So allocated cell is this one. This is these 1, 2, 3, 4, 5, 6 cells are allocated cells. We are calling this one basic cells. நாங்கள் இதில் பேசிக் செல்ஸ்ன்னு சொல்லுவோம். இந்த அலோகேட் பண்ணின செல்ஸ் எல்லாம் මත සෙල් එලම් non basic cells ன்னு சொல்லுவோம். So අපි කියන්නේ මේක allocate කරලා තියෙන ඒවට allocated cells basic cells කියලා කියනවා. අනිත් ඒවා ඔක්කොම non basic cells, allocate කරපු නැති ඒවා non basic cells. So allocated cells, we are counting the allocated cells and number of cells, right? Number of cells are how much? 1, 2, 3, 4, 5, 6. So altogether 6 cells allocated, right? So m plus n, m is a row, n is a column, right? So number of row 1, 2, 3. Number of row is m, 1, 2, 3. So 3 plus n, number of column 1, 2, 3, 4. 4 columns are there, minus 1. So 3 plus 4 is 7, minus 1 is 6. This is equal to this. So there is no degeneracy problem. There is no degeneracy problem. No degeneracy problem, right? So this one, if it is there, we have to do some other thing. So normally in question point of view and exam point of view and other time we are not doing this. They will not give you a degeneracy one. So only no degeneracy will be given to you, right? So this is what we have to do first, right? Next, the second part. Right. So this is our question, right? So I hope it's clear to you all. Wait. Okay. So let's see here, right? Let's see here. So first we have to find two things. One is for non-basic cells. For basic cells, first we have to name this one shadow cost u1, u2, u3. Here v1 columns are v1, v2, v3, v4. We are naming this columns v1, v2, v3, v4, and rows u1, u2, u3, v4. Right. So here u1 plus v1, right? u1 plus v1 is this cell, right? So only I have to write here for the basic cells. This is allocated one. Basic cell, you know, right? Allocated cell. So basic cell is 5 is a basic cell. So u1 plus v1, right? So u1 plus v1 is equal to, right? So it is equal to, so what is that? Your cost is 10. So it is equal to 10. You have to put here cost. Then other one is u1 plus v2 is 2. u1 plus v2 is 2. Right? So next u2 plus v2. u2 plus v2, how much? 7, right? 7, yes. 7. Next, here, this one, u2 plus v2. This is v3, no? v3, sorry. So u2 plus v3. u2 plus v3 is 9. Right? This is 9. u2 plus v3 is 9. This is 9. u2 plus v3 is 9. Then u2 plus v4. u2 plus v4 is how much? 20. Then u3 plus v4 is 18. 1, 2, 3, 4, 5, 6. Altogether 6 equations we got. So here for these cells, for these basic cells, we have to do something. We have to check the row of maximum allocation. Which one? Maximum allocated is only 2, here 3, and here only 1. So 3 is here, no? So here 3 allocation, 5, 15, 5. So that u2 is, we have to make it as 0. You have to assume u2, assume, if say here 3, no? So here say for example u1 column have all the allocations, so all the allocation for 4 places. Maybe it's maybe maximum allocation row we have to select. Okay, we have to select the maximum allocation row. So maximum allocation row in this question is u2, so that I am selecting u2 is equal to 0. If u1 line row have maximum allocations on 1 2 3 4 have mean, so here only 2. If it is 4 mean, we have to make u1 as 0, right? That is the first thing we have to do. So u2 is 0. u2 0, after u2 0, so think here. So u2 is 0. So u2 0 mean v2 is 7, right? u2 0 mean v2 is 0. v2 is 7. So v2 7 mean u2 0 mean v3 is how much? 9. 3 is 9. Here from this v3 is 9. So u2 0 mean v2 is 7. Okay, u1 plus v2 is 2. So you know v2 now 7. So u1 is equal to minus 5, right? Is equal to minus 5. u1 is equal to minus 5. So here u2 plus u2 0. So v4 is equal to 20, right? So u3 plus v4, you know v4 now 20. So u3 is equal to minus 2, right? Minus 2. So u2 you know, u1 you know, u3 you know, v2, v1 you need v1, right? So here v1, u1 is equal to how much? Minus 5. So v1 is equal to 15, right? Yes, v1 is equal to 15. 15. So 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Yes. So u1 you know, u2 you know, u3 you know, v1 you know, v2 you know, v3 you know, v4 you know. Now you all the values of the shadow cost you know now, right? So now next what we are doing is for non-basic cells. For non-basic cells, right? Here to check the optimality, right? To check optimality, so we are doing to find optimum value. Optimum value we are doing this, right? So for non-basic cells, right? For non-basic cells, so non-basic cells you know, right? So this one is non-basic cell. So no allocation there. So u1 plus v3. u1 plus v3 is 20. So for non-basic cells, there is a condition for non-basic cells. Right? That condition says, so ui plus vj minus cij to be less than or equal to 0 to find optimum value. So I mean what we have to do is we have to check all the ui plus vi minus cij, everything to be 0 or equal to less than 1, less than 0, right? So minus values maybe. If it is a plus value, positive value if this gives, so your solution is not an optimum one. So you have to go for the other one, other part, mean Modi method or stepping stone method to find the optimum value, right? So that is what the thing concept. Now you may understood, right? So what I am going to tell is, I am going to do is for basic cell, for non-basic cells, select right. So I am writing here, right? u1 plus v3 minus Cij is what? What is the value? 20 equal to how much? So next, u1 plus v4, u1 plus v4 minus 11 equal to what? Next non-basic cell is u2 plus v1 plus v1 minus u2 plus v1 minus 12 equal to how much? So next one is u3 plus v1 minus 4. Next u3 plus v2 minus 14. Next u3 plus v3 minus 16, right? Next u3 plus v3 minus 16. Next u3 plus v4 minus 18. Right, these values, we will find the values. u1 plus v3 is u1, you know, u1 minus 5, right, minus 5. So let's select another color. Right, let's see. What is the value? Minus 5. u1 is minus 5, v3 is 9 minus 20. Right, here u1 is what? u1 is minus 5, v4 is what is the value? 20 minus 11, minus 11. Here u2 is 0, v1 is 15 minus 12, u3 is minus 2, v1 is 15 minus 4, u3 is minus 2, v2 is 7 minus 14. So u3 is minus 2, v3 is 9 minus 16, u3 is minus 2, v4 is 20 minus 18. Okay, so minus 5, 9, say minus 25. So say 4 minus 16, right? 16. Say minus 5, 20 minus 11. Say minus 15. So here you can see here, right? Here you can see minus 5. u1 is minus 5. v4 is 20. This is 11. So here 9, right? Here 9 minus 5. Here positive, right? Here positive is there. Positive 4. Right, positive 4. Here we will see 15 minus 2. Here there is a positive value 3. Again here 15, here minus 4, minus 2, how much? So minus 6 means again positive value, right? Again positive value 9. Here maximum. So minus 14, minus 2. Here 7. So this is a minus value, right? So minus 7, minus 9. Here minus 2, minus 16. So this one also a minus value, right? 18. So minus 9. Here also minus 20 is 0. Right? So when we think about this one, here there is 3 places there are issue. This is not equal to 0 or less than 0. These are greater than or equal to 0. So this is problem. So here we have to think the maximum one. We have to select the maximum one. Yeah, this is the maximum one. We have to select this maximum one. And this is 9. This is the maximum. U3V1 cell. U3V1 cell is this one. Which one is the U3V1 cell? This one is the U3V1 cell. U3V1 cell. This is our U3V1 cell. So for this cell, right, this cell, what we have to do is, now this is not the optimum value. So we have to conclude the value we found here, this one is not the optimum value. So if you want to find the optimum value, we have to go for MODI method or stepping stone method, right? So MODI method. So we will move there. So how to do the MODI method work? So let's see here. Selecting this one. Okay. So this is the column. This is the cell. So maximum cell. So this U3V1 cell, maximum positive value. Our maximum positive value, this value is 9. So here that cell U3V1. So that cell I selected now. Right? So what we have to do is here, so we have to find a loop. Right? So we can find a loop here to go here, here, and come. Also, we can find a loop here to come here and go there and come here. Right? So other than that, so our loop to be through the allocated cell. Right? So allocated cell, the loop to be, so little maximizing I have. Wait. Okay, let's see here. So what I am going to do is I am going to find the loop. Let's use this color, right? Okay, so our loop. So our loop to be through the allocated cells, right? Allocated cells mean basic cells. So here, so this side I am moving. So there is a, so I mean we have to move through horizontal or vertical. Only horizontal or vertical we have to move, right? So I am moving here to this place. So now the place where I have the cell is here. This is the cell, we have the allocation. So that is the basic cell, I have the basic cell here. So in this direction if I go, so there is the allocation only this place, there is no allocation here. So I have to turn here, this direction now. So I am turning, and I am coming. So I am coming and I am coming. Here there is no any allocation here, so I can't come here. So this is not the possible loop. If there is any allocation here, it is a possible loop. This is from here start. We have to start from this place, right? We have to start from this place. This place I am moving here and moving here and moving here and coming here. So this is not the way. So here I am moving and here I am moving and here I am moving. So if there is any cell, if any allocation here, it's okay. The loop is correct loop. So the corners allocation cells are there. So here no. So this is not the possible way. Okay, this is not the possible way of loop. Right? This is not our loop. So we have to find the loop. So next way is finding a loop through here. I am moving here. So there is in this corner there is a allocation. So here I will come here. Now I am going to come here and here. So there is no allocation. So this is not the possible way of allocation. Possible loop. So this is not the correct way, right? So what I am going to do is, I found a loop only this way. Here I am moving and I am moving here. There the corners allocation cells are there. So corner allocation cell, here corner allocation cell. I am coming this way. There in this corner there is the allocation cell. So I am moving here. This corner also there is allocation cell. So I am coming here. This corner also there is allocation cell. I am coming here and I am end up with the same cell. So this loop have a allocation. This loop have an allocation. Every corner should be an allocation. Sometime your loop may be not this kind of breaking loops. It may be a kind of a this and this and this, and only maybe a kind of rectangle or triangle. Sorry, rectangle or your square shaped loops may become. So in this case, the special case, this is a kind of a loop. I found that the corners are allocation cells now. So only this not have the allocation. Okay, let's see. Now what we have to do is in this loop we have to find the solution. So for this special case, so we have to find the minimum allocation, right? Minimum allocation. So here what we have to do is we have to put plus and minus here, right? So starting from this our started place, okay, our started place, what we have to do is okay, I will use this one, and I am going to put the plus and minus notation now, right? So here I have to start from here plus, right? So next I am moving maybe this direction or that direction. So here this is one is negative, this is negative, right? This is negative. So in this corner, this is a corner, right? So this is negative and this is a positive. This is for positive. Then we are giving here a negative. We are giving here negative, positive, negative, positive, negative. Here we are not putting anything. Here positive, here negative, here positive. So starting from positive, we end up with the positive value, right? So what we are allocation in our negative values, right? In our negative values, we have to find the minimum value, right? We have to find the minimum value. So negative minimum is least one, right? So in here least one is where, which one is the least one? Here negative 5 and 10 is there, right? Where the least one is the allocation least one, right? 5, 10, our allocation, black curve allocations. So least one is 5. So 5 is the allocation. 5 is our least one. So we have to start from here 5. So 5 mean we have to separate table. We have to draw this one. We have to write this one in separate table. But what I am doing is here I am not doing like that. So directly I am using this table in separate color, right? So because of time problem, I am doing that, right? Okay, we will select. Say I am using this yellow color. Okay, this yellow color. Okay, so here I am allocating 5 here, positive 5, right? Positive 5 here. Next, if I add positive 5 here, so I have to reduce negative 5, right? Negative value is there. Here I have to reduce 5, right? I am adding 5 here, positive 5, right? So from this allocation, I am going to subtract the 5 here. Negative notation. So minus 5. Color is not clear, no? So let's choose another color. So brown. We'll choose brown. Right. So check negative 5. Negative 5. So here positive 5. Positive 5. Right. Here this corner positive, no? Positive 5. So positive 5. So I am putting positive 5 here. This corner negative 5, no? Negative 5. Negative. So this corner positive 5, no? Positive 5. This corner negative 5, no? Negative 5. Notation is there, negative. Okay. So now I am correcting this one. I am correcting this one. And just say I am drawing this one here. Let's see here. How many tables are there? How many cells are there? 4, right? Altogether 4 and 3. Right? So here, and these are A, B, C, D, A, B, D, and these are S1, S2, S3. Okay. So now here this one S1A, this one become 0 now. Here there is no allocation here. S1A becomes 0 now. There is no allocation here because plus 5 minus 5, right? So here 10 plus 5, this is S1B, it become 15 now. It's become 15 now, 10 plus 5. So here it is going to become 0 now, right? So here what is S2B, S2B, this is going to become 0 now. This allocation is going to become 0 now, right? Next here, so S2D, this allocation going to become 10. S2D, the allocation is going to become 5 plus 5, 10. So 10 minus 5, so S3D 5, 10 minus 5, 5. S3D is going to become 5. So here, now our S3A, it's going to become 5. S3A is going to become 5. So positive 5. So 0 plus 5, right? So now think about this one. Now you can see the row also. Now there is no any change in the row also, right? So this is allocation is 15 now. Now it's become 15. So there it is 15, right? No any problem. Here it is 0. Here altogether this is 15. Here this 10. So 10 plus 15 after changing it is 25. No any problem. So in row also, if we check the here also, 10 minus 5, it is 5. Already here 5, we are adding 5 here. So 5 plus 5, it's 10. So no any problem in the row. The same thing you can check column also. Also there will be no any problem by doing these changes, right? So let's see again. Okay, let's see again with these values. With these values, let's see again let's see this one. This check, our optimality check again for this one, again for this same place, same problem with this change. With this change, we are going to check the optimality, and we are checking whether all the values it's becoming a 0, less than or equal to 0 or not. So wait. View. Right here, this check, we are going to do this check again, this one, right? So this check we are going to do again with this value. So now our total cost, if it is come by giving this allocation, right? We change the allocation now, right? By using the Modi method, we change the allocation. By creating a loop, we change the allocation. Now with this changed allocation, we can find the total cost now, right? You know how to find the total cost. Here 15 mean 15 multiplied by what is the for S1B, what is the cost? S1B is 2 rupee. So 15 multiplied by 2. So the final, the total cost for new one total cost is equal to 2, and 15 multiplied by 2 plus 15 multiplied by 2 plus another one, S2D, right? S2D is 2 D 20 rupee. So 20 rupee 10 multiplied by 20 rupee. So S3A is 5 multiplied by 4 plus S3D 5 multiplied by 18 5 multiplied by 18. Now we can end up with 30 plus 200 plus 20 plus 50 80 90. So altogether 50 140, so 340 rupees, right? Give me a time. Okay, let's start here because of time taking problem. So I'm shorting this one, the calculations. So after finding this one, we founded the so already we founded that this one is the first, our initial basic solution is not the optimal one, so we move to Modi method. From the Modi method, I told you how to how to do the loop things and allocations. The changed allocation also I explained you here. I changed the allocation also, I explained you. By having this allocation, the changed allocation, what I am doing is again the earlier way of finding for basic cells and this non-basic cell calculation, these two things. අපි මේකේ තියන්න මෙන්න මම කලින් කියපු basic cells එකෙන් කරපු මේ part එකයි non basic cells එකෙන් කරපු මේ part එකක් ආය කරන්න ඕන මම. හරි, දැන් අපි change කරපු allocation එකට. හරි, දැන් loop එක හදලා කරපු change කරපු එකට අපි හදන්න ඕන. Hari, okay. Then what we are going to do is so next what we are going to do is, so for this one again I have to do these calculations for basic cells and non-basic cells. So after that I will get this kind of, so the changed one. So these are allocation cells. So the allocation cells U1 U2 I mean this one is the allocation cell. So this S1B is S1B. So U1 V2 is the allocation cell. For this allocation cell, wait. For these allocated cells here, what we are doing is here for these allocated cells, so U1 V2 is 2, U2 plus V2, all the things we will get. So only one what I am going to do is here 0 cell I have to select. So this one is 0 and this one is 0, one cell. So this cell I maximum amount I selected here. And I founded all the calculations here. So after finding these calculations for non-basic cells also I have to do the thing, and all the thing will become minus below 0. It is a minus value. This the optimum solution for our final value. This is the basic. The solution for this one is feasible solution, and the basic feasible solution will give the optimum value. So that optimum value you can see the comparison. This is 520, this one is 340 rupee. So you can find with the different here also. So this is the optimum solution for that one. So total cost become minimized here, right? So this is why how we are doing the Modi method of that one. So I already told you how the allocation is there, and here only one I have to do is here U1 V2 the allocation, the basic cells I already keep. So only one I have to do is, so there is a 0 no, so there is a 0 will come to these two places after changing using the Modi method. So one selected cell I choose here, and I allocated that one as a basic cell. I consider that one as a basic cell, and I did this assumption, and I founded the shadow cost values. So after that the values, so I am going to put here for non-basic cells, and and then basic cells, all the values I will found, so those are becoming a negative value below 0. So the basic cell, I mean the basic feasible solution what I got from this allocation is this the value. This value will give you a basic, I mean the optimum value, optimum solution, right? So the next video I will explain you the initial. I already told you the northwest corner method and other two methods for finding the initial basic solution. So the initial solution, basic solution, those two methods I will discuss in the next video. So keep watching the video. And for the same solution, the Modi method of this, if it gives a optimality check, is the same for that one as well, right? So after doing that one, what I am planning to do is I will do the planning, project scheduling work of activity on node method for you all to I will plan to explain that one, right? So thank you very much for watching my video. Thank you. I hope this video will keep a clear guide to you all about the this transportation algorithm questions, right? Thank you.